Hello and welcome to a Mr. Panza video lesson on how we use algebra to solve for function tables. We've talked about function tables and algebra. Now we're going to piece them together to help solve for missing rules in function tables. Let's look at the steps. First, you need to check and see if the rule is possibly increasing the answer or decreasing the answer. And then the difference is in step 2. If the answer seems to be increasing, that means the rule is either multiplication or addition. If the answer is decreasing, then the rule has to be either division or subtraction. So when you see if it's increasing or decreasing, you need to check with your calculator, is it multiply or addition? If it's division or subtraction. And you can see if it's increasing or decreasing that it will cut your options in half. Then, once you've determined what the rule has been, you follow step 3. Apply that rule to every single piece of the table. If nothing works, you need to check for multiple steps. For example, maybe they multiplied first and then they added. Or maybe they divided first and then subtracted. Let's take a look at a couple of examples. Here's our function table. We have the complete function table filled in, but we don't know what the rule is. So let's take a look back at step 1. First, I need to check to see if the answer is increasing or decreasing. Well, the answer is the out portion of our table. So I need to compare that with the in. The numbers going in, are they lower or higher? Or the answers itself, is this increasing from the original number or decreasing? 6 to 18 is an increase, 4 to 12 is an increase, 5 to 15, that's an increase as well. So now I know that I can look at step 2, and step 2 tells me to check if it's multiplication or addition. So they either multiplied or divided to jump from 6 to 18. I just need to determine what's going to be the case. So if they added, then I know that it was 6 plus something that got me 18. That reminds me of something. This is where algebra comes into play. So if I were to do my work here on the bottom, I could show you that I know, well, it's either 6 plus the variable x equals 18. Oh, I remember algebra. I can take what I know and do the inverse operation, 18 minus 6, which gets me 12, and that's going to solve for x. So it's possible that the rule is plus 12, but you have to try it out for a couple others just to verify that that's accurate. So 4 plus a variable will get me 12. Again, use algebra. Take the information that you know and do the inverse operation, the opposite operation. 12 minus 4, 11, 10, 9, 8 is going to get me 8. So it can't be plus 12, because even though 6 plus 12 gets me 18, 4 plus 12 is not going to get me 12. So that means it has to be multiplication. Let's try it out. 6 times the variable x equals 18. Now I remember that when I'm using algebra, I take what I know, and because it's multiplication, I'm going to divide. 18 divided by 6 is 3. Does that work? 6 times 3 is 18. It works. Now try it out with your second portion of the function table. 4 times the variable x equals 12. Take what you know, the 4 and the 12, and because it's multiplication, you're going to do the inverse operation and divide, and 12 divided by 4 is going to get you 3. 4 times 3 is 12. So that means our rule is multiply by 3. It will work for every single one of these. 5 times 3 is 15, 7 times 3 is 21, 3 times 3 is 9, and 10 times 3 is 30. We used algebra to solve for this equation in the function table. Let's look at another example. In our second function table, you'll notice that the numbers are decreasing. We're going from 18 to 12, 10 to 4. So back at my rules, it tells me that if it's decreasing, I need to check for division or subtraction. And how can I check for division or subtraction? I use algebra. I'm going to take 18, and because it's decreasing, let's try subtraction. Minus x, my variable, equals 12. Now remember, subtraction can get a little tricky. So if you forget the rule, just double back and think. I've got to take what I know again, and the variable is second, so do I do the inverse or do I do the actual operation of subtraction? Well, in this case, I am going to subtract and get 12. Because the variable is second, I do the actual operation. 18 minus 12 is going to get me 6. 18 minus 6 is going to get me 12. So let's see if minus 6 works for the second input function. 10 minus x, which we know we're going to try and apply 6, should equal 4. Let's try algebra. Because the variable is the second piece of the equation, I have to subtract. 10 minus 4 gets me 6. 10 minus 6 gets me 4. We used algebra to recognize that the rule is subtract by 6. You can apply these algebra rules each time to solve for function tables. Let's take a look at one more function table. What's the rule here? Let's see what they're doing. First of all, they're going from 20 to 5, from 8 to 2. They're decreasing. So I need to see if we are subtracting or dividing. How do I solve for that? I use algebra. I have 20. I'm going to say that maybe they subtracted a certain variable to get 5. How do I solve for that variable? I take the information that I know, and I either do the inverse operation, or in this case, because I'm subtracting again and my variable is second, I'm actually going to subtract. I do 20 minus 15, which gets me, 20 minus 5, which gets me 15. And when I plug that 15 in for x, it works. 20 minus 15 equals 5. But is minus 15 going to work for 8 and 2? Absolutely not. So I have to try another operation. In this case, I'm going to try 20 divided by x. So I know that when I'm multiplying or dividing, I check with division. Take the information you know, do 20 divided by 5, 5, 10, 15, 20. That gets me x equals 4. Let's plug it into the equation and see if it's right. 20 divided by 4 equals 5. That works. So the rule is probably divided by 4. Let's check it out. 8 divided by 4 is going to get you 2. 4 divided by 4 will get you 1. This rule works. The only one we haven't shown you is the tricky one, and that's when you have multiple steps. Let's take a look. In this case, I can try my steps, but you're going to notice that the one-step process will not work. I recognize that the numbers are increasing, so I know that they are either adding or multiplying. So let's try addition first. They take 3 and they're going to add some variable, let's call it x again, to get me an answer of 7. In order to get to 7, what did they add? Let's try algebra. Take what you know and do the inverse operation. 7 minus 3 is going to get you 4. So that certainly works there. But would plus 4 work for 5? No, because 5 plus 4 will get you 9. It also won't work for 7. 7 plus 4 is not going to get me 15. In fact, when I try multiplication, it's also not going to work. The second step is to try multiplication. So it must be 3 times x equals 7? Wait, nothing times x equals 7. 3 times x would never equal 7. So what happened here? They applied 2 steps. They did multiply. It was 3 times 2, which got them 6, and then they added 1 more to get 7. You'll notice it works for 5 as well. Can times 2 plus 1 work? 5 times 2 is going to get you 10, and plus 1 more would get you 11. It works for 7 and 9 in this function table, and it's really the only time that algebra kind of doesn't pick up where you're really trying to solve. So in order to answer this question, how do we use algebra to solve for a function table, you need to remember the steps. First, check to see if the answer is increasing or decreasing. If it's increasing, they're typically multiplying or adding. If it's decreasing, they're dividing or subtracting. Then apply the rule to all in the table. If nothing seems to work, you need to check for multiple steps, whether that's addition first then multiplication or vice versa, or division first and subtraction. They probably use 2 steps. Thanks for stopping by. We'll talk to you soon.